All right, so today we're going to talk about latent heat and kind of making up the pieces that we missed on Wednesday that kind of guide into the water cycle. We have to first discuss how in the water cycle things are fluid, pun intended maybe. We can move from solids such as snow, ice, glaciers, things like that, into things that are liquid, rivers, oceans, rain, into things that are vapor or gas, such as water vapor in the atmosphere, things like that. So what we are going to break down today is this graph that you guys should have seen before in your lab part A. On our x-axis here, we've got a change in energy. As you recall, when you read a graph, you read from left to right. So this is more energy added, and this is less energy. Same thing with our y-axis over here, we've got temperature. The further down to the origin you go, it's less, and the higher up you go is more. So on our plot of energy versus temperature, we've got a slope in this region here. This is our solids until we come to a certain point. We'll talk about that in a second. This is essentially the change in state that we have. Until we get to our liquid phase here, and then we'll go up to a certain point and we'll have the same transition here until we get up to our gaseous state. So we've got our three states of matter here. Now we have to talk about how we transition between them. So most of you, if not all of you, should be very familiar with a lot of these phase changes. So between solids and gas, when we go over from a solid to a gas, that phase change is called melting. And when we go from a liquid to a gas, that phase change is called evaporation. Some people will call it boiling. That's fine too. So now we've got our direction, how we go from solids via melting to liquid, from liquid via evaporation over to gas. Now if we were to work in the other direction, we should be familiar with all of those processes as well. When we move from a gas to a liquid, we call that condensation, or condensing. When we move from a liquid to a solid, that is called freezing, much like the ice cubes in your freezer. All right, so we've got our big ones that we all should have prior knowledge about. Some of the ones that we may not have prior knowledge about are going to be our phase changes from a solid to a gas and from a gas back down to a solid. So when we change from a solid up to a gas, this is called sublimation. Sublimation, you can remember, starts with S, so does solid. You're starting from the solid phase when you are sublimating. When you move from a gas to a solid, this is called deposition. You're depositing the gas into a solid phase. So now that we've broken this down, this is a lot of our prior knowledge, we can really start to read the graph a little bit more and learn the little nuances that are in it. So along these horizontal lines, we see that we are changing energy, but we are not changing temperature. We're not moving along this y-axis of temperature at all. We're only moving our location along the energy axis. So we are either adding or subtracting energy from our system. We are not changing the temperature. And that, friends, is the definition of latent heat. It is a change in energy without an associated change in temperature. So our latent heat zones are going to be these flat sections where we see the special phase changes happening. Now, we can talk even further about this in how they are interacting with the energy. So when we add energy to the system, to our molecules, that's going to be our melting process, It's going to be our evaporation. And it's going to be our sublimation. These are all adding processes. Adding energy to the system. When we are subtracting energy from the system, we're moving closer back to the origin. These are going to be our processes that move the other direction. So condensation, or we should start with the matching one, freezing. The one that moves this way, condensation. And the other one that moves this way across the graph is deposition. And these are all subtracting energy from the system. Or our little molecule, our molecule of water or so is our system. So since these are subtracting energy from our molecule, where is that molecule's energy going? It does not just disappear. The energy within the molecule is being subtracted and added to the environment. So it's kind of a give and take process. So these ones, while they are subtracting energy from our molecule, they are warming up the environment around them because that's where their energy is going. So these ones give energy to the environment, and that warms the environment. However slight of a warming process that it is. Over here, these ones that are adding energy to the system, where does the energy come from? It comes from the environment. It's pulling energy from its surroundings to warm itself up. So these ones, while it's warming up the molecule to change its phase, it's actually cooling the environment around it, however slight. So these ones are taking energy. And thus cooling the environment. So in our latent heat graph that we have here, what we're really looking at is the latent heat here of fusion. We're fusing things into a solid or removing them from their fused state. And the latent heat of vaporization over here. So we have fusion and vaporization, and this is the latent heat of them. And remember, the latent heat is the change in energy without an associated change in temperature. So it's only those areas that are flat lines in here and in here. And that's latent heat.